So in this video I will be discussing Codeforces around 960 for division 2. So I will be solving till problem C and telling you the only intuition part of problem C. So let's now discuss problem A, that is summation bait. In this question you are given two players Elias and Bob playing a game in an array of size n, and they will turn operation one by one with Elias starting first. So what you have to do, you are given a initially a variable mx which is initially set to 0. And in one operation, what you can do, you can choose any index I such that it is greater than or equal to mx and set a of I is equal to 0. And the last player who plays the turn will win. So you have to tell whether allies can win or not. Okay, so let's now try to simulate the process here. For example, this is your array. So tell me, can allies win or not? So if I tell you, allies will always pick that number whose occurrences are only odd times. Okay, so in this array, my one is that number whose occurrence is odd time. Okay, Elias will pick that number. Now the numbers which are left are having occurrences even number of times, which means if they are numbers whose occurrences are even number of times, that means that the player who is starting the game, who is starting the first even number will not end the even number. Let me tell you the what I'm trying to say. Let for example, if Bob chooses this two, then Elias will choose this two, which means Bob will never have a chance to choose another two, right? Which means if a person is starting picking the element whose occurrences are even, then he will not end the game. Okay, so that's why if there's any number whose occurrences are odd, then the allies can win. Okay, let me tell you another case. For example, this is 2 2 4 4. So in this uh, so in this case, allies will be starting first, right? And all of the numbers are having even number of occurrences, which means allies will never be ending at the last. Okay, so which means Bob will be ending last. So if Bob is ending last, which means Bob will win. So let's suppose allies pick this, then Bob pick this. Okay, then allies pick this, and then Bob pick this. Okay, so here you can clearly notice allies starting first and Bob ending last. Though this is the case if none of the number having occurrence odd. Let me take another case like 3 3t and 2 2. So in this case, like Elias will choose this two. Okay, first of all, then Bob will choose this two. Okay, now tell me whether, so in this case, let Elias will always start with the greatest number having the odd number of occurrences, that is 3. Okay, now Elias is starting with these 3, which means Elias will be ending 3 only, right? So now Bob will choose this 3 and Elias will choose this 3, which means Elias is playing the last 10 and Elias will win. So the clear induction is that if any of the number is having odd number of occurrences, then that player would win, else another player would win. So that's how you can solve problem array. Let's now discuss problem B, that is array craft. So let's now discuss the problem B here only because the problem statement is itself very unclear. It is clear but somehow confusing. So you will be given three integer number a, n, x, and y. Okay, and your x is always greater than y. Uh, Greater than y. Now, for example, you are given an array like this. Uh, for example, this is the array element. This is an array given to you. Okay, great. Now what you have to do, you have to select, for example, you are given a, I'm telling you that this is the integer, this is the index x. Okay, this is the integer x. This index only. These are x and y are both indexes. For example, I'm telling you this is index x. So what does index x represents? So index x simply represents that the sum of, like I'm writing it here, or I can write the prefix sum till 0 to x. Okay, prefix sum to 0 to x is equal to maximum of maximum of all the prefixes sum. Okay, all the prefix sum. Let me write it here. All the prefix sum from 1 to n. So this is the integer x represents. That prefix sum of 0 to x is equal to maximum of prefix sum of 1 to n. And x is the smallest such index possible, right? And let me tell you the what is integer y represents. For example, this is integer y. So integer y represents that suffix of y till n is equal to maximum of all the suffixes from 0 to n. So this is the suffix represent, and this is also the minimum possible index. You can check the condition also. uh, you can check the condition also, right? And the maximum suffix position says that b is the largest index that satisfies the condition, right? B maximum position of b is largest index I that satisfy the following condition. Okay, so hope so the problem statement is clear to you. Like, now what you have to do, you will be given integer number n, x and y, and you have to find array which satisfy the condition such that at index y the prefix sum of 0 to x is equal to maximum of all the prefix sum, and suffix sum of y to n is equal to maximum of all the suffix sum from 0 to n. Okay, hope so the problem statement is clear to you. So, but now how to approach this problem? Uh, Let me now discuss the that part here. Okay, so for example, you are given an array like this. I'm again taking array. Mm, okay, for example, these are the array elements given to you. Now what you have to do? For example, your x lies here at this position. Let me write it here x, and your y lies here on this position. Okay, now how to approach the problem? Now you know one thing, that if you are taking prefix sum, so let now discuss first of all x only. Now if you're taking prefix sum, okay, if you're taking prefix sum, you know one thing, that this prefix sum is maximum, right? And after that, for example, the prefix sum at this position, let's suppose it will be 5. Okay, now you know one thing, that in this array, like in this sub array, there is no prefix sum whose sum is greater than 5, right? all of them should be smaller than all of them should be smaller than or equal to 5, right? Okay, now this condition is satisfied to you. So how you can choose this, you choose this subarray. First of all, let me focus how you can choose this subarray. Now you now you're also given a condition that each and every element should be 1 or minus 1 only in your array. Okay, and you also know one thing, that your this subarray cannot be greater than 5, which means at this index you're getting the maximum sum, and after that you cannot increase the sum. Okay, if I cannot increase the sum, I can simply make it minus 1 1 minus 1 1 minus 1 1 minus 1 and 1. So by writing it like this, you will never be increase you will never increase the sum which you are getting at this position, right? Am I right? Yes, I am right. So similarly, if I take another example, for example, this only, let now I will tell you with respect to y. So if this is your y position, if this is your y position, and you know one thing, at this point you are getting a maximum suffix sum, which means the sum of this, sum of this, sum of this three, sum of this four, five, similarly all of them. So at this point you are getting a maximum suffix sum. After that you will never increase the suffix sum. You have to maintain the suffix sum. So to maintain the suffix sum, what you will do? You will write minus 1 here, 1 here, and minus 1 here. So by writing it in this sequence, you will never increase the sum. And you are also given a condition that your x is always smaller than y. Okay, that is also satisfied. Now tell me one thing. If all of these number are minus 1, 1 minus 1 1 minus 1 according to y, and all of these are also 1 minus 1 1 minus 1, and there are some number always between y and x. You know also that thing, because it is constant itself that y is always smaller than or equal to x. So if you write 1 1 1 1 1 here, if you write all of them as a 1 here, wouldn't it be a nice answer? Yes, it is the right. It is the answer, right? But why? So you know one thing, let me repeat it again. At this point you are getting a maximum prefix sum. After that you cannot increase the prefix sum. So you will simply write minus 1, minus 1, minus 1, 1, minus 1, 1, minus 1, 1 in the alternating order, because by writing it in this sequence you will never increase the sum. Remember one thing, the index which is next to the x should be minus 1 always, right? So by writing it in this sequence you will never increase the sum. Similarly for the y, because you know one thing, at y position you are getting a maximum suffix sum. So by all the numbers which are previously of your uh, index y, you will write it in the sequence minus 1, 1, minus 1. And remember one thing, the index which is next previous to y should be minus 1. So isn't and all the numbers which are between the y and x should be 1. So by writing it this sequence you will always get the answer, because you know one thing, by so let me tell you why it will work with respect to x. First of all, you know one thing, these three integers are 1 minus 1, 1 minus 1. So okay, maximum sum this can yield would be 1, or maximum sum the minimum sum which they can be yield should be minus 1. Okay, 1 or minus 1, this can be 1 minus 1 0. Okay, 1 minus 1 0, they cannot be except these three numbers, the sum of prefix sum of these three numbers. Now you know one thing, all of them are 1. All of them are 1. Yes, all of them are 1. So by adding number of ones in this sequence would be maximum, would be making prefix sum at this position would be maximum. Yes, this is true. And you know also one thing, I have already take care of the rest of the prefix sum. I have made them smaller than or equal to this x only. So don't forget that case. At this point you are getting the maximum prefix sum. Similarly for the suffix sum. Similarly for the suffix sum. You know one thing, that this subarray is 1 minus 1, 1 minus 1, which means maximum suffix sum at this position would be either 1, either minus 1, or either 0. Yes, is it true? Yes, it is true. And you also know one that thing, that all of the number between x and y are 1, which means this suffixum would always be increased. So if it is increased and stopping at this position, that means this is the maximum suffixum, and after that suffixum you are alternating minus 1, 1, minus 1, 1. And by writing it in this manner you will make sure that at this position you are getting the maximum suffixum possible. So that's how you can solve the problem. Okay, so let me generalize the solution. You will be given three integer numbers n, x and y. You will be given three integer number n, x and y, right? Okay, now what you have to do, between each and every number which are coming between x and y, mark them as 1. Mark them all of them as 1, and right starting from x, mark them as 1 minus 1, 1 minus 1, 1, and right before y, mark them as minus 1, 1 minus 1, 1 minus 1, 1. So that's how you can solve the problem. Okay, so let me show the code also. So if you are given three integer number n, x and y, okay, first of all mark all of them as 1. Okay, now what you will do, mark all the numbers which are between y and x as 1, and starting from the next integer itself, x plus 1 till n, mark them as minus 1, 1 minus 1, 1, and right starting from y minus 1 till 0, mark them as minus 1, 1 minus 1, 1, and print the array at the end. So that's how you can solve the problem will be. So let's now discuss problem C, that is mad sum. Okay, so what is the definition of mad? That is maximum appearing duplicate. So you are given an array, for example you are given an array, and what is the mad of that array? The mad of that array is that number who is largest and who is occurring more than twice, more than or equal to twice. Okay, that is a mad number of that array. You can see the definition also, largest number that appears at least twice in the array, that is a mad number. Now you're given an array, initial array. So let me tell you the question here only. Okay, for example you're given an array like this, uh, 2 1 1 2. So first of all find mad at each and every index. Okay, the mad at this index is 0. Yes, there is no number which is occurring twice. Yes, the mad at this position is also 0. Yes, The mat at this position is 1 because 1 is the largest number who is occurring more than twice or equal to twice. Write it 1. Now mat at this position is 1. No, it is 2 because 2 is that number who is largest and occurring more than or equal to twice. Write it 2 here. Now again find mat at each and every index of this array. Okay. Now mat at this position is 0. Mat at this position is again 0. Mat at this position is again 0. And mat at this position is again 0. Okay. Now at the point you are getting all of the zeros in your array. Stop at this position and find the sum of all the arrays which you have been currently passed on. The first array was this. The first array was this. Find the sum of this array, that is 4, 6. Okay. Find the sum of this array, that is 3. Okay. And this array is 0. This array is 0. Now sum of all this is 9, and that is what you have to return. That is what you have to return. So how to solve this problem? So I will tell you the intuition of this problem, how you can approach this problem. You can code it yourself. Okay, so let me take some example of this problem. Let it be like 3. I'm taking a random test case. 4 0 6 0 0 6. Let it be 3 again. 9 10 9 and 10. Okay, let I am taking this array. This is a random array. Okay, so first of all write the mat at each and every index of this initial array. Okay, the mat at this point would be 0 3 3 3 again 3 again 3 again 3, but at this point it is 6 because 6 is that number who is occurring more than or equal to twice and it is largest also. Again it is 3, again it is 6, again it is 6, again it is 6, but at this point it is 9, and at this point it is 10. Okay, now you will notice one thing that your each and every index is occurring twice, or and your array is in sorted order. Yes, yes, my array is in sorted order, and my each and every index is occurring twice or once. And first of all, and most important thing, that your array is now in sorted order. Again perform the operation. Write it mad array each and every index 0 0 3 3 3 3 3. Here it will be again 3. Here it will be 6 6 6 6 and 9. Okay. Now have you noticed one thing? What you have done? You have just popped out the last number, and rest each and every index is same. Rest the sum is same. For example, the sum of this is, let it be y, and your last number is a. Okay, your sum of this array would be x plus a, and a is the last number. Then the sum of next array is only a because the last number has been popped out of the array. The last number has been popped out of the array, and the rest of the array is same. Right? Isn't it nice? Or you can find the pattern in this problem. Yes. So how you can approach this problem is simply just brute force the two operations, right? Just brute force two operations. Like this. First operation is this, second operation is this. Just brute force two operation. So after brute forcing two operation, you will make sure that your each and every index is occurring twice in your array, and your last number is only number which is occurring once, and which can be occurring once. And rest each and every index would be occurring twice in your array. Rest you can Rest you can simply generalize the solution. But how? Let me tell you how you can generalize the solution. For example, this, let me take the 3. Let me now first of all consider 3. This is 3. Now tell me how many times 3 is occurring? 3 is occurring total 6 times. Okay. Now you also know one thing. How many times these 6 threes will be there in the array? That will be number of arrays, number of elements which are on the left of the array. Okay, how many elements are on the left of the array? That is 1 2 3 4 5 6. Okay, they total 6 elements in the left of the array, which means this 6 3 will be surviving 6 arrays, right? Let me repeat it again. These 6 threes, these 6 threes will be surviving 6 arrays, right? So can you multiply the sum of all these threes, like 18 into 3? That is simply 18 into 3, right? Which means this is a constant sum. After that, what will be happening? After that, 1 1 3 will be popping out at each and every at each and every array, which means you will simply adding 18, then it will be 15, then it will be 12, then 9, then 6, then 3, and then 0. Then you have to simply add this only in your final answer. Just repeat this for each and every index, and you will finally get the sum of your whole array. Let me repeat the solution again. First of all, brute force it till two operations. After that, you will realize that each and every number is occurring more than twice except the last number. It can be once or it can be twice. But now what you have to do for each and every element, for each and every element, you will notice that these occurrences will be occurring at most the number of elements which are on the right of this subarray. Okay, just simply multiply the number of occurrences into number of elements on the left. Okay, you will get your sum at the point these number will be surviving in your array. Okay, great. After that, each and every number will be starting popping out of array, and just add the sum and repeat it for each and every index. For example, these sixes. How many six are there? Let me erase this part. How many six are there? There total. mm, Let me erase this. There are total four sixes. Okay, there are total four six, which is 4 into 6. This is 24. Now tell me, how many arrays will this? How many array will this six will survive? They will be surviving two more subarrays. They will be surviving two more arrays. Simply multiply it with 2. Okay. Now you will get 84, 82, 48. Now you know one thing. After this, your each and every 6 will be starting popping out. Which means if it is 24, then next sum would be 20. Next sum would be 18, then next sum would be 12, then 6, and then 0. Add this sum in your this sum, and you will get the answer. You can simply find the pattern to find this sum, and that's all for this today's video. And hope you like the video. Please don't forget to subscribe and share the channel. Till then, stay tuned for the next one. Thank you.